Hi, math students. Today's lesson is going to focus on a topic called literal equations. Literally. I swear. I defined literal equations here. The first bullet says a literal equation has at least two different variables. And secondly, common literal equations are often called formulas. Like think about your formula for perimeter. Perimeter, let me write this up here, like perimeter is 2 times the length plus 2 times the width. See, that's the formula for perimeter, and it has 3 different variables, which is at least 2. Or maybe area of a rectangle, area equals length times width. See, 3 different variables, okay? So these are literal equations or formulas. Okay, so we're going to use our equation solving skills to solve some of these examples. It's going to seem a little weird because you're used to getting like your final answer to an equation. You're used to getting like x equals 7. You're not going to get that today. Your answers are just simply going to be manipulations of the equations you're given. You'll see here in the first example. So let's take a look. It says solve for B. Okay, so here I'm going to blow this equation up because these are really tiny. So I'm going to write AB plus 7 equals C. So hopefully you can see that better. And we're solving for B. So we have to get B alone. But right now, B is tangled up with not only this positive 7 that's being added here, but also this A that's multiplying. So if you remember the analogy I made in a class, whatever variable you're solving for, the things or the numbers or the letters that are furthest detached from it, get rid of those first. So remember we talked about this plus 7 being like Uncle Joe, where the A that's right next to it is more like a brother or a sister. So we want to get rid of Uncle Joe first. So the way to get rid of a positive 7 is to subtract 7 from both sides. And some of you like to draw that line down the middle at your equal sign. So you know positive 7, negative 7, they're inverses, so they're going to cancel to 0. And so on this side, you're left with A times B equals, now here's where it gets a little strange. You're going to write this side exactly the way it reads, C minus 7. You can't do anything with this. If C was a number, if this was 10, well, 10 minus 7 would be 3. But this is a C, and these are not like terms. So we can't combine them, so we just have to write C minus 7. Okay, now we're still trying to solve for B. Now we want to get rid of brother or sister A. So A and B are being multiplied, and the operation that undoes multiplication is division. So I'm going to divide both sides by A. Reason being, A divided by A cancels out to 1. And I'm left with B, which is what I was looking for. So B equals C minus 7 all over A. That's your answer. Isn't that weird? Okay, now here's the thing. You can actually write this one other way, and I want to share this with you. I'll go through it slowly once, and then hopefully from here on out, you'll just remember it. There is another way to break this down. When you have what we call a monomial denominator, see, mono means one. See how this is just one term, A? There are no pluses, there are no minuses, it's just A. When you have this situation, you may take anything in the numerator connected by pluses or minuses and separate it over this denominator. So you could do this, C over A minus 7 over A. So either one of these answers is acceptable. Now, if you wanted to go backwards, like say you wanted to turn this into this, well, think about your fraction work in elementary school. A and A, you have a common denominator, so when we subtract two fractions with a common denominator, we write that common denominator once, and we add or subtract the top. So C minus 7, C minus 7. So this is your answer, either way, two different ways to solving for B. Okay, let's look at example 2. Solve for z. We're going to get z alone. So it says, I'm going to blow it up here, x minus z equals y. Okay, well, here's z. So we need to get z alone. Now there's a couple different things you could do here. You could add z over to this side to make it positive and then move your y over here. Or you can do this. You could, since you want to get z alone, we could take this x and pull it on over to this side. So why don't we do that? Why don't we leave z still and minus x, minus x. So these will cancel, leaving me with negative z equals, over here, it would just be y minus x. I'm just going to write that just like it is. I'm almost there. I almost have z alone, but I have this negative in front, which is like a -1. So I'm going to divide both sides by -1. Cancel these out, and I'm going to have z equals y minus x all over -1. Now you can leave it like that, or like we did above, you can split it apart. So you could do y over -1 minus x over -1. And if you really want to be creative here, you could go even one step further. Y divided by -1 is negative y, and x divided by -1 is negative x. So you have negative y minus negative x, and then we can actually turn minus a negative into positive. So negative y plus x. So it just depends on how far you want to go. If this was like a multiple choice question, you would have to stop when you saw one of these answers. Maybe your answer is this. Maybe your answer is all the way simplified. Okay, example 3. Solve for w. 3w minus m equals r. Okay, so we're solving for w. So 3w minus m equals r. Bring that through. Okay, here's my w. So I'm going to go ahead and add m to both sides. Trying to ice, I'm getting rid of Uncle Joe here. Cross them. 3w equals r plus m. R plus m. And now we're going to divide by 3 because we want to isolate w. So w equals r plus m over 3. Or we could do this technique, monomial denominator, r divided by 3 plus m divided by 3, which actually, because there are ones here, 1 and 1, in front of the r and the m, that's actually could be written as 1/3 r plus 1/3 m. So lots of variable manipulation going on here. Okay, let's check out example 4. Solve for m. It says m plus 5 divided by 9 equals t, and we got to get m alone. So the first thing we're going to do is multiply both sides by 9 to clear that 9 away. So that will cancel these 9s out, leaving me with m plus 5 equals t times 9, which is the same as 9t. And now solving for m, I can just subtract 5 from both sides. So m will equal 9t minus 5. Done. And the last one on the front side, solve for e. D plus 2, blow that up, d plus 2 equals 12 minus e. Okay, well, I'm solving for e. Here's e. So my first step will be to move the 12 over to the left. So I'm going to subtract 12, cancel. So this gives me d minus 10, when I take 2 minus 12, equals negative e. But I don't want negative e, I want positive e. So I'm going to divide both sides by -1. And that is going to give me e equals d minus 10 divided by negative 1, which, if we go through and split it up, is going to be d over negative 1 minus 10 over negative 1. And d divided by negative 1 is negative d, minus 10 divided by negative 1 is negative 10. And negative d minus negative 10, this can turn to a positive, so negative d plus 10. So this is acceptable, but so is this. Depends on how far you have to simplify. And again, if it's multiple choice, you'll know how far to go based on your answer choices. Okay, thanks for watching Literal Equations. Hopefully this will help you do your mastery work.